Curl. What is curl? Curl is the circulation per unit area or rate of rotation at a single point. This is one of the basic definitions of curl, and we can also define curl mathematically in such a way that curl is equal to the cross product of a continuous differential vector point function f and vector differential operator. This is the mathematical representation of curl, where del equals to I partial over partial x plus j partial over partial y plus k partial over partial z, and vector f equals to f sub 1i plus f sub 2j plus f sub 3k. So the cross product of del and vector f equals to I j k partial over partial x partial over partial y partial over partial z f sub 1, f sub 2 and f sub 3. I can see here that I, j and k are common, to have I, j and k in the first row, and then take all the three derivative terms here, and obviously f sub 1, f sub 2 and f sub 3 in the last row. This is called curl. Physical interpretation of curl. Curl represents angular velocity. If there is any angular velocity in an object, we can use curl. Let's say, for example, there is an object. If it rotates either clockwise or anti-clockwise, it creates angular property. So as long as it creates angular property, I can use curl. Take any object. The wheel of a car is rotating. Any object that rotates about a point and creates angular velocity deals with a curl. But in case if the angular property does not exist, then the curl will be zero and the vector is called irrotational vector. As I mentioned in introduction that curl will be used only if there is any angular property. But if the angular property does not exist in an object, the curl will be zero, and that vector is an irrotational vector. If the curl equals to zero, then the field is irrotational vector field.